Alright, this next video is going to cover chemical bonding, in which we looked at ionic bonds, covalent bonds, and metallic bonds. When chemical bonding occurs, is this a chemical or a physical change, and how do you know? A chemical bond is a chemical change because you're changing the properties of each substance and forming new compounds. So the first thing we covered was the difference between just an atom and then an ion. So in this one we're looking at the aluminum ion. You're going to look up aluminum in your periodic table to find the atomic number. The atomic number is 13. The mass number would be protons plus neutrons. So since I didn't tell you that there's a different number of neutrons, we're going to assume that there's 13 neutrons, and 13 plus 13 should equal 26. For the total electrons, since this is an ion, you need to go back and you need to count all the electrons in the picture. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then you need to go back and count just your valence electrons, which is just the electrons in the outside. You would count 1, 2, 3, 4, 5, 6, 7, 8. So those are what I highlighted in green. And the reason it has 8 valence electrons is due to the octet rule. You need to try and get 8 in every single element except for hydrogen, helium, lithium, and beryllium. They only want to fill up their first energy level. The symbol for the aluminum ion, you would go with the symbol in the top, which is Al, and then you have to figure out the charge. And you figure out the charge by adding protons and electrons. So in this one we have 13 protons. Protons are positive, so that's a positive 13. And then you count the electrons. So the total electrons was 10. Electrons are negative 10. 13 minus 10 equals 3. And you have to think, which one is the bigger number, 13 or 10? 13 is the bigger number, it's going to be plus 3. So when I write this into my symbol, we actually reverse those. I'm going to say 3 plus. So the symbol is Al, 3 plus. So for instance, on the test, you might get a question that I give you a picture and I ask you, is it an atom or is it an ion? You could count up your protons, count up your electrons. If the numbers are same, it's an atom. If the numbers are different, it's an ion. So in this case, we have 13 and 10. Those are different. That's why this is an ion. Okay, what are the two types of chemical bonds and what happens to electrons in each? The two major types of bonds, we have our ionic bonds. And in ionic bonds, we're transferring electrons from a metal to a nonmetal. The metal becomes positive, and the nonmetal will be negative, so it has charges. The second type we covered was a covalent bond, and instead of transferring, they share electrons between 2 or more nonmetals. No charges. Since you're not transferring, you don't get to calculate a charge. But in both ionic bonds and covalent bonds should have a neutral compound. In the first picture, we're looking at Li and O. And there's a couple ways you can figure out whether they're ionic or covalent. The first thing I would do is look at whether it's a metal or a nonmetal. If you look up lithium in your periodic table, lithium is a metal. Oxygen is a nonmetal. If you have a metal and a nonmetal, that should be ionic. And if it's ionic, you can see that it lost this electron to go to oxygen to fill in that space. And it did the same over on the right side too. If you lose electrons or you gain electrons, that would be transferring electrons. The next one, we have hydrogen and oxygen. Hydrogen is a nonmetal. Oxygen is also a nonmetal. Two nonmetals would make the compound covalent. And in this picture, hydrogen is not losing an electron. It simply moves over so that both hydrogen and oxygen can share their electrons. So in this one, they're not transferring, they're sharing. And in these two, we're looking at whether it's an atom or whether it's an ion. And the first thing you should do is count your protons, count your electrons, and figure out your charge. So in this one, it says you have protons equals 3, and you can see that by those little red dots. So 3 times plus 3 should give us that you have a charge of 3 plus. Okay. In this one, you're counting the electrons. I'm going to highlight those. You only have 2 valence electrons and 2 total. So our charge for the electrons, we're going to take 2 times -1, or you can just say electrons are negative, it's -2. And to calculate our charge, we're going to take 3 minus 2, which gives us 1. Take the charge of the bigger number, which is 3, so it's going to be +1. And the symbol would then be, and this is where you need to use your periodic table. You're going to look up the protons. There's 3 protons. Lithium has 3 protons. And then you're going to write the charge to be 1 plus. So we're moving to the right now. We know that there's still 3 protons. Protons are +3. And if you count those electrons in the outside, you should count 1, 2, 3 for all of them. Remember, you have to count all the electrons when you calculate the charge. Electrons are negative, so that's a -3 charge. 3 minus 3 is a charge of 0. If you have a charge of 0, you don't write that into your symbol, you just put the symbol name, which is Li for lithium. For the next one, we have 19 protons, which would give us a +19. And if you counted all of those red dots, those are all your electrons. You should count 18. Electrons are negative, which is why it's -18. 19 minus 18 gives you 1. 19 is the bigger number. You're going to say it's +1. And then find the name of the element in the periodic table. So this one, 19 protons gives us K. And then put the charge. We're going to say it's K, 1 plus. And then to the right here, we still have 19 protons, which gives us a +19. You have 19 electrons. -19. 19 minus 19 is going to be 0. If you have a charge of 0, the symbol is just going to be the letter K. So let's go back now and figure out if they're atoms or ions. In this one, we had 3 protons, 2 electrons. Different numbers gives us an ion. In the next one, we had 3 and 3. Same is atom. You have 19 and 18. Those are different numbers, should be ion. 19 and 19 are the same numbers, atom. Okay, the same idea for the next 2 here. You have 17 protons, which gives you a +17. You have 17 electrons, which gives you -17. 17 minus 17 is 0. 17 protons gives you that it's chlorine. If it has a charge of 0, you are not going to put the 0 at the top. You're just going to leave it as it is. 17 and 17 are the same number. That tells you it is an atom. To the right here, we have 17 protons still, so it's +17. We have 18 electrons, which is a -18. 18 minus 17 is 1. The bigger number is negative. -18 is bigger, so it's -1. Write your symbol. If you have 17 protons, you're still looking at chlorine. And then you're going to put Cl with the charge, which is 1 minus. 17 and 18 are different numbers, which tells you that this one should be an ion. Okay, on the bottom, we're looking at 12 protons for magnesium, which would be a +12. You only have 10 electrons. If you count all those red dots, you should only count 10. Electrons are -10. 12 minus 10 should give you 2. The bigger number is 12, which is positive, so it is +2. And the symbol for this one is Mg. With the charge, it's going to be Mg2+. 12 and 10 are different numbers, which makes this an ion. The next one, you have 12 protons, so it's still +12. You have 12 electrons. Electrons are -12. 12 minus 12 is 0. And the symbol is just going to be Mg. Don't put the 0 on the top. If the numbers are same, 12 and 12 are the same, it should be an atom. In this one, instead of giving you electrons and protons to draw, I drew all the electrons for you, and then you're going to count to figure out if it's an atom or an ion. If you count all your electrons here, starting on the inside, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. you have 10 electrons. And I'm going to say that's negative 10. Now this one I did not put the protons on the inside because I'm checking to see if you know how to calculate the atomic number. You just look at the periodic table for the number of protons. Fluorine should have 9. And then you have to remember that protons are positive. That's going to be a positive 9. Neutrons, since this is an ion, we're assuming it has the same number of protons and neutrons, you would just say 9. And in order to find that 1 minus charge at the top, you're going to add electrons and protons. We're going to say 10 minus 9 would give you 1, and the bigger number is negative 10. So we have positive 9 minus 10 equals negative 1. And that's how you get F1 minus. We're going to do the same for this one. We have sodium. If you count all the electrons, all those blue dots, you should count 10. That's a negative 10 because electrons are negative. Na has 11 protons, positive 11. We're assuming that it has the same number of neutrons, unless I say something different or I give you the mass number. And in order to get that charge, we're going to take protons and protons plus electrons. We're going to say positive 11 minus 10. The bigger number is positive. It needs to be positive 1, which is how you're going to get this charge. 1 plus. And the same thing for the next one here. If you count all those electrons for aluminum, you should count 10, which is negative 10. You have 13 protons, so it's positive 13. You should have 13 neutrons because I did not tell you that the number was different than protons, and I did not say it was an isotope. Find the charge by taking positive 13 minus 10. 13 minus 10 is 3. The bigger number is positive 13, so that's positive 3, which is how you got the 3 plus. In another problem just like that, we have 10 electrons. Electrons are negative. Oxygen has 8 protons, positive 8. You should have 8 neutrons. Calculate your charge by going back and adding electrons and protons. You have a positive 8 minus 10. So 10 minus 8, you can do the reverse, would be 2. And the 10 is a bigger number, which is negative, so it's negative 2. Which is how I got the 2 minus at the top. Here you have one more problem like this. This one you have to count all those electrons. So if you count in the inside, you have 2. In the next one, you have 8. In the last one, you also have 8. So 2 plus 8 is 10. 10 plus 8 is 18. So you have 18 electrons, and that should be a negative 18, since electrons are negative. Protons, you can see in that periodic table box, you have plus 17. Neutrons, we're assuming, is the same as protons. We're going to say positive 17. Oops, just 17, no charge since it's neutral. Go back, calculate your charge. We're going to take positive 17 minus 18. 18 minus 17 equals 1. The bigger number is negative, so it's going to be negative 1. That's how I got the 1 minus. Ionic compounds was the first compound we covered. Once we covered ions, ionic compounds form a three-dimensional pattern, and since it's repeating, it has a pattern. It's called a crystalline lattice. Remember the difference between crystalline and amorphous. Crystal have patterns, amorphous do not. The properties of ionic compounds, the easiest way to remember this would be ionic compounds have high melting and boiling points. And the way I like to remember that is I rhymes with high. High for ionic compounds. We also remember that they are brittle. So they're brittle, crystalline, high melting, and boiling points. When we name ionic compounds, you would write the first one. The first one, if you look in your periodic table, B is boron. Then you're going to write in fluorine. And you have to go back. You're going to find that second vowel, which is the I, and take out everything after it and change it to IDE. Same for the next one. So this one should be boron. And you can write bromine. Okay, then you have to find the second vowel, it's I. Take out everything after, change it to IDE. Start with lithium, fluorine. Find that second vowel. The reason we're not counting U and O is it's a diphthong. Technically, they're counted as one vowel. And change it to IDE. The next one, you should have lithium. And you write in phosphorus. Find the second vowel, it's this O, change it to IDE, so that one is lithium phosphide. When I'm giving you the name and you have to go back to the formula, you have to do a couple different steps here. The first thing you should do is look at the name, find the symbol, and then you have to calculate the symbol's charge. So we have sodium is Na. Na has 1 valence electron, so you have to think, is it easier to lose 1 or gain 7? It's easier to lose an electron. If you lose an electron, you now have more protons, so this should be Na 1 plus. Sulfur symbol is S. Sulfur has 6 valence electrons, and you have to think which one's easier to get to 8. Should I add 2 to get 6, or should I lose 6? Pick the smaller number. You're going to add 2 more electrons. Electrons are negative, so this one should be 2 minus. S, 2 minus. In order to get your compound to be 0, you have to think, I have a positive 1 and I have a negative 2. How do I get that to 0? You'd have to add another Na 1 plus. Okay, so when I'm doing the math here, I'm going to say a plus 1, a minus 2 equals 0. So when I write my formula, I'm going to say, how many NAs do I have? I needed 2 positive 1s, so I need Na2, and I only needed 1 of those negative 2s from sulfur, which means it's just Na2S. You do not put the number 1 into your formula. Same one is exactly the one on the bottom that has sodium, so we're going to put Na1 plus because we calculated that on the top. Phosphorus is a new element, so we're going to put phosphorus is the letter P. Phosphorus, if you look in your periodic table, it has the number 5A on top. It has 5. It's easier to add 3 electrons, so it's going to be 3 minus, so P3 minus. Then you have to think, how can I get this to all add up to 0? I need 3 positive 1s, so I'm going to put Na 1 plus, and I'm going to do that again. So to show my math, to get the compound to 0, I have positive 1 plus another positive 1 plus another positive 1 minus 3 equals 0. So for my formula, I had 3 positive 1s, which is going to say Na3, and then I had only 1 phosphorus, so Na3P. We have sodium again. We know sodium is Na1 plus. Okay. Fluorine has 7 valence electrons. You're just going to add 1 electron, so that's F1 minus. A 1 plus and a 1 minus is already going to give you 0, which means you don't have to change the numbers of atoms. You're just going to have 1 of each. It's going to be NaF, no 1s in your formula. Last one we have magnesium. Magnesium is the letter Mg. Magnesium has a 2A on top of the periodic table, so that is a 2 plus. Chlorine has a 7A on top of the periodic table. You're going to add 1 electron to get to 8, so it should be 1 minus. Now you have to have a 2 minus. We're going to say Cl 1 minus again. So for my math, I'm going to say a positive 2 minus 1 equals 0. So we have only 1 Mg, and we have 2 Cls.
The second quiz we had was on covalent compounds, naming covalent compounds, and drawing covalent compounds. So remember, the major differences between ionic and covalent compounds are that covalent compounds will share electrons, they will not have charges, they will be neutral, and we also use this chart on the bottom to help us name compounds. So most commonly we're going to use mono, di, tri, occasionally tetra. So the first name I give you is dihydrogen monoxide. We know that hydrogen is the letter H. If you look at that table, H is 2. Okay. Oxide would be oxygen. And if it's mono, it means 1, but you don't put that 1 into the formula, so it's just H2O. Carbon dioxide, if it's just carbon, you only have 1 of them. Oxide is O. Di means 2, so it's CO2. Dihydrogen dioxide, it's hydrogen, so you have capital H, di for 2. Oxygen is O, and you would have 2 because it's dioxide. So on the bottom three practice problems, we're doing the reverse. So if you have 2 phosphorus, I'm not sure why those numbers are close to the top, you would have diphosphorus, and you have 5 oxygen, so 5 is penta, say pentaoxide. The next one, you have 2 nitrogen, that would be di, so dinitrogen. And there's 1 oxygen, so you'd say monoxide. Again, we have 2 nitrogen, so dinitrogen. And in this one, we have 3 oxygen, so trioxide. Okay, it says draw the compound, is it covalent or ionic? The first thing I would do is figure out if it's covalent. So H2, you would have 2 nonmetals, which makes it covalent. And I'm going to draw this with protons, neutrons, and electrons. So I'm going to say P equals 1, N equals 1. I'm going to draw my circles. I'm going to put my electrons in. Before that, I do that, I'm going to do another hydrogen because I have 2 of them. And once again, they both have 1 proton, 1 neutron. And make sure that your circles are actually touching each other. Then I'm going to add in my electrons. I'm going to do 1 electron for my first hydrogen. I'm going to put that in the middle. My second hydrogen also has 1 electron. So right now I want 2 valence electrons in that first energy level. Next one we have NaCl. So the first thing you need to do is figure out if it's ionic or covalent. You have Na, which is a metal, and Cl is a nonmetal, which makes this an ionic compound. That means you should be transferring electrons. And you should have charges in your drawing. So I'm going to start off with my protons and neutrons. Na should have 11 protons, 11 neutrons. Draw your first energy level. And draw a second one. And then I'm going to draw Cl. Since it's ionic, I'm not going to draw them touching each other because they're not going to be sharing, they're going to be transferring. Cl has 17 protons, 17 neutrons. I'm going to draw in my energy levels. Okay, I'm going to put my electrons in. Sodium has 2 in the first energy level, then 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to need 1 more energy level. And I need a total of 11, so I'm going to put 1 more electron in. And then I need to draw my chlorine, so I'm going to put 2 in the first energy level, 8 in the next. And then I'm going to put 7 in the outside. So looking at this, you have to figure out how to get 8 valence electrons for sodium and how to get 8 valence electrons for chlorine. So I'm going to take out my valence electron from sodium, and I'm going to add that to the chlorine. Now I need to calculate my charge. So in the first one I have 11 protons, that's positive 11. Now I have only 10 electrons, it's going to give you positive 1. I'm going to put that charge up in the top. My sodium should be 1 plus. And my chlorine I have 17 protons, 18 electrons. gives you -1, so the charge is 1 minus. And your way to check to see if your drawing is right is to go into the bottom, add your charges together. I have +1, -1, should give you 0. Compound is neutral. Next one we have LiF. Figure out if it is ionic or covalent. Li is a metal, fluorine is a nonmetal, which means it's ionic, and it should transfer. It should have charges. So we'll draw the first one here. Li has 3 protons and 3 neutrons. I'll draw my energy levels in here. Got my first one. Draw a second one. Okay. Then I also need to draw fluorine. Fluorine has 9 protons, 9 neutrons. Draw your energy level in here. And then I will add my electrons. So lithium has 1, 2, 3. Fluorine has a total of 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And you have to figure out how to get a full valence electron level. We're going to go back to lithium, take out the electron, and now add that into the fluorine. Oops. And then go back and calculate your charges. You have +3 minus 2 equals +1, so it's 1 plus. And you have +9 minus 10 equals -1. And calculate and make sure your compound is neutral. +1 minus 1 equals 0, compound is neutral. Alright, for the next compound we have H2O. H is a nonmetal, O is also a nonmetal, so we have 2 nonmetals, which makes this a covalent compound. We should be showing our elements sharing electrons. The first thing you should draw is oxygen. Because oxygen, there's only one element, so it's going to be in the middle. Oxygen has 8 protons and 8 neutrons. Then you're going to draw the first energy level. We're going to draw the hydrogen. And hydrogen has 1 proton and 1 neutron. Draw a second. And then draw the energy levels for hydrogen. Okay, and for oxygen, we should have 8 electrons. We're going to start with 2 in the middle. We should have 6 in the outside. And hydrogen is going to have 1 electron for each atom. So the way you know you have your drawing correct is that you should have 8 valence electrons on the outside for oxygen. Hydrogen only wants 2 valence electrons in the first energy level to fill up just the first shell. So it goes 2, 8, and 18 for your energy levels. When we draw on the Lewis dot diagrams, you're only drawing the valence electrons. You're going to look at the number that's on the top of the periodic table that has an A after it. So lithium, if you look at the top of the periodic table, it should say 1A. You're just going to draw 1 valence electron. Fluorine should have 7. And boron should have 4. And Na has 1. I made a mistake there. Boron should actually only have 3. It's a 3A above that number. I'll go back and erase one of those. Okay, and the next one says, what is a diatomic molecule? A diatomic molecule is a molecule that has 2 of the same elements. So in the questions below, it says circle the molecules below that are diatomic. In the first one, we have H and H both are the same, that's diatomic. O and H are not the same, so it's not diatomic. And we have Cl and Cl, that is also diatomic, 2 of the same. A metallic bond is a bond formed between at least 2 or more metals due to metals losing electrons. So the metals will become positive, and they are attracted to the free floating electrons on the outside. Why are only metals capable of metallic bonding? And the reason for that is that metals have few valence electrons. Most of the time it's 1 or 2. And those electrons will leave to have 8 valence electrons. And this creates the sea of electrons. So all those little red dots in that picture are just free floating electrons from their metals. How does an electric current form in metals and allow us to generate electricity? So like I said on the other page, metals create a sea of electrons. They give off valence electrons to have 8 valence electrons. So they have free electrons that can move through a wire. So in a battery you have a plus side and a minus side, and that has to do with the plus side would have less electrons and the negative side would have more electrons, kind of similar to how we calculate an ion. So if you break up the word electricity to try and find its root word, electricity is made of the word elect, which means electron. So that's the whole reason we have electricity, is that the electrons move through the wire. This is just a quick guide. You can take a look. Kind of summarizes everything we've done for the entire chapter. What are the major differences between ionic and covalent and metallic bonds? And that was everything for our chemical bonding unit.